Okay, it's my great pleasure to introduce Professor Mauro Dorato from Roma 3, University of Roma 3, who is one of the most, in my view, creative philosopher of physics that writes philosophy of physics today. And it's a great pleasure that he's with us today. Among other things, he published a book a few years ago, which I think is a gem. It's misleadingly called The Laws of Nature, the software of the universe, because he doesn't believe in this view. But the laws of nature part of the title is true, and it's a great book. I wish it's going to come out again by a publisher which makes it still available, because it's almost out of print now, I think.
Yeah, it's Ashgate died.
Yeah, and it's a wonderful book. Look it up. Okay.
Tell me when I'm 5 minutes.
Yeah, I will. Time starts now.
Okay. Well, fine, yes. Thanks a lot, Orly. Non-formal thanks, and to the institution that funded this great initiative. I want to start from these 4 related facts. There's a sort of one-way dialogue that started, I guess, after the Los Alamos project. Before 1950, there were a lot of physicists that were deeply interested in philosophy. Bohr, Einstein, Weil, Schrödinger. After 1950s, of course, we have this beautiful example of Rubin. But I can hardly think of other physicists that really have an interest in philosophy. There is this process of metaphysicization. It's a horrible neologism. Philosophy of science turning into metaphysics of science, or even analytic philosophy.
What is POS?
Sorry?
What is POS?
It's philosophy of science. I'm sorry, I'm using acronyms. I'm sorry. In order to be philosophy of science to philosophy of the single sciences. I'm sorry. Thanks for your question. And the fragmentation, the second kind of fragmentation is this: there seems to be no shared method for pursuing philosophy of science. And here I see a big risk of meta-philosophy. How should we do philosophy of science rather than doing philosophy of science? And the questions are, can a two-way dialogue be reestablished between philosophy of science and the single sciences? And the first question seems to presuppose relevance. Can philosophy of science still be relevant to the single sciences? And can the philosophy of the single sciences be relevant to philosophy? Does philosophy of science have a non-metaphysical future? And finally, pluralism should one of the ways of pursuing philosophy. These are my theses on relevance. I think we should distinguish between the first sense and the second sense of relevance. Philosophy of science, this is what the first sense tells us, contribution to the internal progress of the science. In the second sense, which I take it to be more important, philosophy of science contributing to an understanding of science in a broad sense, like the place of human beings in the universe. And my fear is that philosophy of science can be relevant to, in the first sense, to science, only if it specializes into the philosophy of the single sciences. But then there is a risk of losing philosophical content. And the second thesis, I don't have time to go over this and give argument, but I wanted to present some of the questions. Fragmentation of philosophy of science is okay, because I think the philosophy of the single sciences give concreteness to general philosophy of science question. I think it favors dialogue between scientist and philosopher. And my final thesis, I think philosophy of science ought to aim for the best balance between this first sense of relevance and the second sense of relevance. But note, please, that philosophy of science depends asymmetrically on the philosophy of the single sciences. For instance, Orly illustrated the importance of case studies. I think this process of metaphysicization is really bad when metaphysics is neither relevant for the progress of science nor for understanding of science. I'll just go quickly on the plan. There's too much here on the board. But I want to give evidence for lack of dialogue and fragmentation of philosophy of science. Some strategies to reestablish dialogue. The heuristic power of philosophy of science will be stressed, but also will be stressed the generation of completely relevant formal results that appear so great from the eyes of a philosopher of science. They respect formalism, but it's totally neglected by scientists. And finally, this is a couple of tendencies in philosophy of science that I think should be encouraged, namely Mach's historical critical tradition. Stathis, I think, gave a good illustration of that. And I want to defend philosophy of science as sort of bridge between the two images. Each of them should be taken seriously. I'm going to skip this, but look, evidence for fragmentation of philosophy of science into philosophy of single sciences. Philosophy of mathematics, probability, philosophy of physics within physics, space and time, classical mechanics, thermal physics, quantum mechanics, quantum field theory, and even quantum gravity. And please know that these sort of disciplines are not practiced by the same philosopher. Philosophy of biology, chemistry, psychology, psychoanalysis, phenomenology. Finally, the social sciences. This is the kind of fragmentation that I was referring to. Well, fragmentation of methods, I think. There's no need to illustrate. This is a quotation, which I found really striking. The worst part of philosophy is the philosophy of science. The only people who read work by philosophers of science are other philosophers of science. I'm going to explain why Lawrence Krauss wrote these lines. It has no impact on physics whatsoever. And it's so really hard to understand what justifies it. This is Freeman Dyson, important physicist in the first part of the last century. Philosopher of 20th and 21st centuries is really going a bit ahead. Compared with the giants of the past, and he's thinking about Descartes, Leibniz, I think, are a sorry bunch of dwarfs. They're thinking deeply thoughts and giving scholarly lectures to academic audiences, but hardly anybody in the world outside is listening. They are historically insignificant. This is Weinberg. Thanks, Orly, for having put this on the board. My talk overlaps a lot with hers. How do we fight against this view that physicists, especially in the second half of the 20th century, have defended? First of all, abandon inferiority complex. First reply to Krauss. Why was Krauss so mad about philosophy of science? Because he just committed a stupid blunder. Because he's confusing the Democritean void with vacuum states in quantum field theory. Because he wants to demonstrate that the universe emerges out of nothing. But this nothing is Democritean vacuum. But really, this is Albert in the New York Review of Books. Krauss seems to be thinking that these vacuum states amount to the relativistic quantum field theoretical version of there not being any physical stuff at all. And this is where conceptual analysis plays an important role, by someone, of course, who's quite conversant with physics. Another reply to Dyson, I think Russell and Popper did both technical work and more popular work that reached a large public. And Weinberg, well-informed philosophers protect physics from conceptual blunders. There's some debates here that are not going to be developing, like Price versus Hawking, Calendars versus Schonkaller, etc. The second strategy, let me please know what you think about this. Again, Weinberg. I think we should try to be much clearer in our prose. I was discussing this with Yuval, whom I thank for being here. These philosophers were very important in reaching the large public because their prose was plain and in some of the works non-technical. Their interests were broad. I think this explains their influence. What's wrong with popularize what we're doing? What we're doing is, of course, based on technical jargon, but scientists popularize science. Why don't we follow the tradition of Le Philosophe, Voltaire, for instance? Why don't we produce novels, movies, theater plays that can play a cultural influence on scientists and the large public? Well, now the second strategy. Go technical about philosophy. There is some sort of asymmetry also for philosophy of physics. I mean, now I'm getting into the philosophy of the single scientists. Philosophers of physics quite often read physicists, but the reverse is almost never the case. How can you solve this problem when on the one end of the big spectrum, where vague distinction exists between Malaman-type scholars, he's a very well-known mathematical physicist, and other metaphysicians working purely on a priori on gunk, for instance, atomless composition of the world. So we have all this spectrum. The former work is certainly relevant in the first sense. It does contribute to the progress of science. I mean, that's what great relativists like Giroche and Wald were saying to me. But Malaman is a mathematical physicist, so the objection is this a philosophical relevant work? And the second work, the kind of work coming out from metaphysicians, could be relevant in the second sense, but certainly not in the first sense. I mean, this is an assertion and I have no time to justify. And that's, again, my push toward a best balance between these two R's. And I think this best balance is possible because the distinction between being relevant in the first sense and being relevant in the second sense is sort of vague. I think that if one formalizes previous philosophical questions, one is still a philosopher. So I think there is a sense in which Malaman is not a purely mathematical physicist because he clarifies certain philosophical questions, for instance, the conventionality of simultaneity, proving formal results. This is an important aspect that I think has not been defended today, but I mean, it has been actually mentioned. These are three cases, historical cases, in which philosophical questions led to science. For instance, the question, what is a demonstration and why do proofs generate knowledge? Philosophical question that led to computer science. A second problem, which was obviously mentioned by Berna, how can we use experience to know or modify our beliefs in a rational way? That led to Bayesian statistics and rational decision theory. What is the nature of mental events and mental states? That was mentioned by Orley. That led to computational models of the mind. They may be wrong, of course, that models, but certainly they constitute an important progress. And here I like this extra example. Einstein's philosophical worries about non-locality led to Bell's inequalities, their testing, and now, of course, there's a lot of technology going on, quantum computer and teleportation. By the way, the first three examples are due to Clark Gleamer. Now, risks of doing formal philosophy of science. According to Gleamer, such questions, those that I was mentioning before, were philosophical because general, non-technical, and falling outside the domain of the known sciences back then. But look, if the fruitfulness of philosophy of science depends on generality, then philosophy of science should avoid excessive formalism and narrow-mindedness, and yet Gleamer seems to endorse a sort of progressive formalization of philosophy of science. But I think there's no contradiction here, but division of labor. There are some technically endowed philosophers that can transform a philosophical, genuine question into a more precise result. And of course, philosophers have to keep on thinking deep questions which are quite general. These are more serious risks for formal philosophy of science. How do we distinguish fruitful questions leading to scientific answers from problems that in principle cannot be formalized? Historically based problems, I think, cannot be formalized. Like how theory changes and theory choice, I think they're left out qua non-amenable to formalization. And formal philosophy of science risks scientific and philosophical irrelevance. Now, of course, I should give some more example. And so it risks neither R1 nor R2. I mean, if you write theorems about the algebraic structure of quantum mechanics, you have to be submitted to the standards of mathematical physicists if you want to really be able to say, I am directly influencing the progress of science. And the role of Bayesianism to understand science is quite controversial. Now, metaphysics is the second important enterprise as a sort of defense of the role of philosophy in the interpretation of physics. The argument is physics is not interested in raising epistemic questions which are typically raised by philosophy. And the general idea is that there are instrumentalists shut up and calculate, or at least representative of the famous NOA attitude. So we are sort of naive believers in the existence of atoms, but we don't care about giving argument about this. But of course, the argument here is that we do need metaphysical notions like propensities, property, event, necessity, substance, identity, to find out what theorists would tell us about the world if they were true. So we need to interpret the formalism in a more critical way. However, interpretation of QM as of now are not relevant in the first sense. I mean, Bohm's quantum mechanics, for instance, has not given any more empirical prediction with respect to those that we already know. But some interpretation, and that's the risk, are derived from ordinary language metaphysics. And these notions, derived from ordinary language metaphysics, may be completely unfit to understand what the theory is telling us. And there's another way to understand the relation between metaphysics and science. Metaphysics describe metaphysical possible world, and science is just invoked to decide about which of this possible world is actually the actual world. Here I have two quotations that are actually in contrast with each other. This is Jonathan Love. Empirical science at most tells us what is the case, not what must or may be the case. Metaphysics deals in possibilities. Here is a colleague of mine that defends this position. Philosophy of science uses empirical science to choose among various metaphysically possible worlds as physicists use possible mathematical structure, which theory of identity is compatible with quantum statistics. Leibniz or X-8ist view, for instance, is an example of this attitude. Or which metaphysics of time is compatible with or favored by special theory or general theory of relativity. But then the question is, what exactly is metaphysical necessity? Or possibility? Is there a metaphysical possibility, a notion of metaphysical possibility, between logical possibility and physical possibility? And my problem is that if you want to use physics in order to determine which metaphysical theory is true, you should bear in mind that metaphysics is even more undetermined by physics than physical theories are by data, for obvious reasons. How am I doing with time, Stathis?
You've got about
10
minutes.
So,
Tweeting your talk.
huh?
I'm tweeting your talk.
So this is my worry about considering the relationship between metaphysics and physics in this sort of way. For instance, in these sort of discussions that Yuval was mentioning before, you use relativity theory in order to choose, for instance, between presentism, the idea that only present events exist, and eternalism, the view that past, present, and future events exist. Well, if presentists really want to be stubborn, they can introduce a privileged frame of reference. As required by presentism, this is not inconsistent with relativity theory as long as you declare it to be undetectable. And if you really want to defend presentism, you can do that. And then, of course, the risk is some of these metaphysical disputes might be devoid of cognitive content, and I'm sure Yuval agrees with me that the distinction and the debate between presentism and eternalism is a little bit running the risk that we're talking about. Now, this is an interesting proposal. Metaphysics first, physics first, or both. two opposing views. Science presupposes metaphysics. Scientists inevitably make metaphysical assumptions. This was, I think, in part what Oli was trying to defend. Whether explicitly or implicitly, scientists propose and test the theory thanks to these assumptions. But this is Einstein. Ex auctoritate, there's a wonderful letter to Schrödinger. Physics first. The true difficulty lies in the fact that physics is a kind of metaphysics because it wants to describe reality. But we don't know what reality is unless we describe it with physics. So argument for both abound. And I think prima facie both views may be true. For instance, science presupposes that there is an external world with a certain given structure, with respect to which our observations are theoretical. You cannot defend the view that observations are completely devoid of a certain content. This is a metaphysical presupposition. And I think it's also true that science relies on ordinary language. The notion of event is presupposed by relativity, even though it's an idealized event. The notion of transtemporal identity. Of course, causation and explanation are very important metaphysical notions. Of course, this is a problem whether causation has a role in physics, but that's a different problem. The notion of intervention is also important from a metaphysical point of view. I mean, scientists don't care about these notions, philosophers do, and it's reasonable to believe that these notions are important to make sense of science in the second sense of the term, namely understand the broad role that science has in our culture. This is the dangers of metaphysicians. The idea is that physics has its own metaphysics. If physics is the metaphysics of nature, Newton defends this view and Einstein defends this view. There is no other way to check its results from an outside metaphysics. And traditional metaphysical notion might just be unfit to understand the world. And its physics is a metaphysics of nature, not the metaphysics of nature. In other metaphysical theories advance competing claims. Physics is to be preferred as far as nature is concerned because you have the help of empirical evidence. As an argument in favor of the idea that physics is, so to speak, comes first, think of the notion of force, space, time, inertia, mass in Newton's Principia, the notion of work, temperature, color, sound perception. They're a newly defined concept. Of course, they take from traditional metaphysics in ordinary language and have a meaning, but only part of the original meaning. So it seems probable to claim that physics has its own metaphysics. This is my take. 5 minutes I have? Okay. I think physics first, not in an ontological, but in an explanatory sense. I have no problem in admitting biological properties or mental properties. But of course you have to use physics in order to explain them. Why am I defending this view? Well, because I think that metaphysics is encoded in our language. The notion of event, identity, substance, just led us to interact with the world in a very successful way. But they constitute a folk theory of the world that evolved in time. There's a folk physics, a folk biology, a folk psychology that have been studied by by scientists. But all of these sciences presuppose science in the sense that you can use science to explain the folk physics, the folk biology. Why is it the case that we naturally think that inertia is so unnatural? Because, of course, we believe that if something moves, there has to be a motor pushing it. So inertia is really a very counterintuitive idea. Why is it the case that we believe that things have to move only if something pushes it behind? And you can use neuropsychology in order to explain that. So the history of physics shows how ordinary language concepts in our naive view of the world evolved. this is exactly what I was saying before. The history of physics, I think, relies on, to a certain extent, from explanations involving dynamic causes, sort of powers explaining why something that I throw over there keeps on moving. But we now accept the idea that inertia is a natural state of things. We have to introduce forces in order to explain why something deviates from inertial trajectories. For Aristotle, it was just the opposite. And free fall replaces gravitational force, and free fall is a natural notion. You don't need to explain that. So we assume the role of dynamical causes, I think because we tend to assume causation as an important notion in order to understand the physical world, but sometimes we have to give it up. Think of Lorenz's explanation of time dilations, for instance. I want to stress why historical critical analysis of science is important. There's another quotation by Einstein, which I love, taken from his, how do you say that? Necrological writing when Mach died. This is the main role that history of science has. Concepts that have proven useful in ordering things can easily gain authority over us, such that we forget their worldly origin and take them as immutably given. They are then rather rubber-stamped as a necessity of thought, and a priori given, etc. Therefore, it's not at all idle play if we are trained to analyze long familiar concepts and to point out upon which circumstances their justification and usefulness depends, and how they evolved, in particular, from the givens of experience. Thereby, their all-too-powerful authority is broken. You show their contingent origins. They are corrected or replaced by others if a new system can be established. So I think this is a thumb up for Mach, the role of history in understanding philosophy. And Sellars, that's one of the guys that I think should contribute to our taking a stance in what philosophy of science should be doing. For instance, the physical now, there is such a thing, reduces to a point. While we believe naturally that it is the point, the now is cosmically extended. Then Einstein, of course, proved that that's not the case. The physical time does not flow, and of course we believe that it does. Unlike the experience now, the physical now is durationless. Now the question is, can we just eliminate the manifest image of time? Can we eliminate the physical image of time? Or should we try to take both images seriously and use one to explain the other? The problem is they conflict with each other, and that's where philosophers, I think, should jump in. There's a conflict of these two images of time. You can go instrumentalist about physics and say, let us not worry about physics at all. It doesn't describe the world. Or you could say, commonsensical view of time is purely an illusion. But if you take the two images seriously, then there is some job that needs to be done. There is some sense in which, by using physics, we have to come up with some ontology for relevant space-time theories, for instance, and clarify our experience of time using descriptive metaphysics, in the sense of ordinary language metaphysics, phenomenology, evidence coming from the cognitive science. So what makes our experience of time possible? I think this is like the idea of bringing together different theories of the world. And what's the relation between the two? I mean, use the scientific image to explain, at least in part, the main features of the time of our experience. So you bring together these two apparently conflicting images. And this is a conclusive quotation. Science and humanism, Schrödinger, the isolated knowledge obtained by a group of specialists in a narrow field has in itself no value whatsoever, I think it's referring to physics as well. But only in its synthesis with all the rest of knowledge, and only in as much as it really contributes in this synthesis toward answering the demand. It comes from Plotinus. I couldn't read this in LaTeX. Who are we? And thanks.
Thank you. This is actually a comment to the last two talks. I'm not sure why we should be so apologetic. I'm teaching philosophy of science at the Weizmann Institute, so I'm teaching graduate students in the sciences, and from my experience, they find philosophy of science very useful to their work. They already come with worries about the evidential standards that they use, the objectivity of the results, the truth of their claims, the gap between the empirical content and the metaphysical interpretation. And they get tools and theories that help them conceptualize those worries and even propose solutions and even formulate to themselves some kind of understanding. And they understand, for example, that they are not Popperians because they accept induction, that philosophy of science hasn't ended with Kuhn, that there are more other ways of talking about the social context of science, that you can be an empiricist and still believe that science works in some way, and so on. I'm not sure why we should take those claims that are not really supported by arguments of some big shot physicist so seriously.
Yes, thanks. Actually, I came through my talk.
Can you stand near the microphone, please?
Sure, I'm sorry. I agree, because your examples, this was also my experience. I taught in a department of physics, and they love philosophy of science. And I think the very good point on what you're saying is that illustrates my claim, namely the best philosophy of science is both relevant in the first sense and relevant in the second sense. This distinction, of course, is a bit of an attempt to create two idealized cases. I mean, of course, we have technically endowed people and people, you know, doing metaphysics that is completely relevant. But I think that the good, kind of philosophical work is in between. I mean, Malamud is a philosopher because he's doing philosophical relevant work in both senses. I mean, he's relevant to the internal and also relevant to understand certain philosophical questions, like when, say, rotation and GR. So I agree with you.
Thanks for an interesting talk. I think that you don't take your second relevance broad enough, or maybe you need to have a third relevance, which is relevance to society at large. You say second relevance is relevance to understanding of the broadening thing, but that's still very academic. And I want to answer a question that you sort of made in passing in the early part of your talk. You pointed out that philosophy of science was more popular with the scientists in the first half of the 20th century and less popular in the second half. Now, I think that you cannot divorce the way people look at science from the outside, or the way people look at science in general, from the way people look at technology. In the first half, in the first half of, like, there's sort of an economic side to this, and a political side to this, and a religious side to this, if you will. The first half of the 20th century, technology was advancing, but one of the biggest fruits of that technology was World War I, with all its horrors. So there was a very ambivalent attitude towards technology. While in the latter part, at least of the 20th century, people started forgetting the wars, and they were all much more enthusiastic about technology. And isn't physics wonderful that it allows all kinds of gizmos? And people forgot about the war, maybe also because of the peace in Europe. But I think there's also a singular event that everybody loves ignoring because it's so horrible. In the end of World War II, in the atomic bomb, is not just a huge technological event. It is also an event of religious significance. we can think of nothing outside of the Bible, or even in the Bible, that is such a huge event. If you look at a nuclear explosion and then you look at the descriptions of Mount Sinai is like, it's not interesting anymore. So in a sense, physics has become the top field after the invention of nuclear power, because they have the most impressive demonstration of the power of knowledge. The idea that knowledge is power is a very old idea, but now they have through knowledge they've created such huge power in nuclear explosions that I think that changes the sociology of knowledge and the whole way that people relate to knowledge. And now physicists are top dog, and philosophy is not interesting anymore. So I think it's political, religious, historical.
Of course. I mean, it's a transition to big science. I mean, you had people like Schrödinger and Born and Einstein that could produce an amazing output of scientific work, basically working in their own rooms. But now think of what's happening in Geneva, the Large Hadron Collider. There's lots of people collaborating there. And then I think in those cases, it's much harder to see the role of philosophy. But I am very much in favor of looking at science as a part of our knowledge in the ethical sense. I mean, a little bit like Cassirer, that thought about the symbolic forms, and science is just one way to describe the world. Then you have aesthetics as well, and then you have myth, and you have politics.
I have a short comment. I disagree with Boaz about the relevance of philosophy of science to graduate students in physics. And so I think, you know, you give us, many of us teach philosophy of science. It's a very captivating kind of topic, and people are interested in, you know, Popper and verificationism, refutations, and so on. My engagement with physicists doing physics has always ended in huge frustration because there was a big barrier of communication. I could not get, and you know, this went beyond you know, intro courses in philosophy of science, trying to see whether there really could be some kind of joint. And no, I think physicists do physics and philosophers do philosophy, and you know, people are curious and interested and broad-minded, and they're interested in hearing each other, but there's no common kind of inquiry going on. And it's very hard to engage physicists with real philosophical questions and vice versa. So I think, and I don't know, I think it's probably not, it doesn't go exactly in the direction you're going either. The relevance of the philosophy of science should be in demarcating what each kind of intellectual enterprise can do, should do, and what it cannot do, and what it shouldn't do. And I think, you know, the broad interest in philosophy, the historically continuous broad interest in philosophy, dims and is put in danger by philosophy of science, because philosophy of science often takes us, explicitly or not, in the direction of physicalism, and physicalism is very narrow in terms of, you know, people's broad interest in philosophy. So I think what we should do as philosophers of science is demarcate and say, this is physics, this is philosophy, this is what physics do, this is what philosophy does, and not try to bring the two together.
Well, my experience in teaching philosophy of science to physicists is different. But I agree that with you that the way they're trained in physics department destroys our attempt to play a role. Destroys our attempt to show our philosophy. In the broad sense, it's important to make sense of what they're doing. You want to understand the world, and of course you have to be very good in computing, but you want to know how your formalism hooks up to what is out there. You don't want to be just Dirac that says, this is my course in quantum mechanics. The only assumption that I make in metaphysics is there is an external world.
Yeah, I too agree with the gentleman's first premise. However, I'm led to a different conclusion, or what I think to be a different conclusion. Maybe the same, phrased in a different language. instead of trying to prove to the physics community or whichever scientific community that philosophy is relevant to that particular science, I do agree that it's good to grow in confidence that we are a community which, and we do our own job, and our job is valuable to civilization also, and also to the understanding of science, just as the job of other communities. But yes, one of our jobs is also, maybe the primary job, is to find ways to demarcate not the community, but the skills of each community. This is where I differ from your view, or not. One of the things that marks us out from scientific communities is that we cultivate different skills. Why within our community, we acquire different skills that scientific communities don't have. No scientific community has the analytic skills that we do in analyzing argument, in constructing argument, in synthesizing argument. And I think that this is what is essential to philosophy of science. This aspect of philosophy of science is essential to science. We are valuable because when the time comes, when the time allows, we have a skill that can supplement scientific skills. When you're doing normal science, as our epoch, as is the case in our epoch, this skill doesn't seem to be valuable. But at other times it may be. And we have to exactly move in that direction. Acquire confidence that our skills are also valuable, even though they are not practically significant nowadays.
Yes, of course, in the first part of the 20th century, you came up with two revolutionary theories, quantum mechanics and special relativity. So these guys were trying to make sense of what they were doing. But in the second part, I'm really generalizing. You're going into a period of normal science. And it's not by chance that people like Rovelli is engaged in philosophy, because all of what they're doing is really pre-paradigmatic. They don't know what they should be doing in order to unify quantum mechanics and general relativity. The second thing that you said, different skills, yes. But how do you use those skills is important. I know people that are very smart, but they're using their skills in a way that is completely irrelevant to science. And there is a trend in this, like purely analytic philosophy, that is neither historical significant to make sense of what happened in the 20th century, nor to make sense of science in the broad sense of the word. It's like going back to scholastics, which, I mean, it's nothing to be ashamed of, but
Look, I mean, I've got a question, but I'm going to skip it in the interest of time. So I think we should talk about that. Before I thank Mauro, which for the wonderful talk, we're around 15 minutes late. I think we pushed the program forward by 15 minutes, so 15-minute break or something like that, and then Stavros is going to be the final talk for the day. So now that we're done with that, Mauro, thank you so much for making us
thank you for your
reflect on what we're doing and why. Thank you very much.